In this video, we're going to learn how to find the existence of a limit using one-sided limits. So here's the main idea of this lesson. The main idea is that the limit as x approaches a of some function f of x, this limit exists if and only if both the left-sided limit, which is denoted limit as x approaches a superscript minus to indicate that we're approaching from the negative side, the left side, of f of x. The limit exists only if this left-sided limit and the right-sided limit, limit as x approaches a plus from the positive side, the right side, of f of x, exist and are the same. So in order for a limit to exist, we require that the left-sided limit and the right-sided limit both exist and are both the same. So let's work some problems. Let's tell whether each limit below exists, and if the limit exists, then let's determine its value. First of all, we want to compute limit as x approaches 1 of f of x, and the graph of f is shown right here. Alright, so in order for this limit to exist, both the left-sided limit, limit as x approaches 1 from the negative side of f of x, and the right-sided limit, limit as x approaches 1 from the positive side of f of x, these both have to exist and be equal. So let's go ahead and compute them. First of all, the left-sided limit, limit as x approaches 1 from the negative side. Okay, so we're approaching x equals 1 from the negative side in this graph. The negative side corresponds to this branch over here, and as we're approaching x equals 1, what is the y value approaching? Well, it looks like the y value is approaching 2. So there we go, that is the limit from the left side. And now let's tackle the limit from the right side, as x approaches 1 from the positive side. So that corresponds to the other branch, this branch on the right here, and we're approaching from the positive side, so we're starting on the right, traveling to the left, going as x approaches 1. As x approaches 1, what happens to the y? Well, the y is approaching 3 up here. So limit as x goes to 1 from the right-hand side is 3. Okay, so we see that both the left and right limit, these both exist. But unfortunately, they are not the same. So that means the limit as x approaches 1, in general, does not exist. Alright, so how about the next limit? Limit as x approaches 1 of g of x. G of x is shown in this graph here. Again, in order to tell whether this limit exists, we have to compute the left and right limits. So limit as x approaches 1 from the left of g of x, and limit as x approaches 1 from the right of g of x. Let's first tackle the limit as x approaches 1 from the left. So we're on this branch here, approaching 1, coming from the left, meaning we're moving right to x value of 1. What does y do? Well, y is approaching 2. So that is the limit from the left equals 2. And then how about the limit from the right? What does this equal? Well, starting on the right, traveling left to approach x is 1. We're traveling this way, the graph is going up, up, up. What's the y value doing? Well, it's approaching 2. So the limit is 2. Okay, great. So both the left and right limits exist. Moreover, they are the same. They both have the value of 2. So that means the overall limit does exist and has the value of 2. Next up, which of the following statements are true concerning the function f of x whose graph is shown below? First statement, limit as x approaches negative 1 of f of x is equal to 1. Second statement, limit as x approaches positive 1 of f of x is equal to 3. And third statement, limit as x approaches 2 of f of x does not exist. Let's just tackle these statements one at a time, starting with the first statement. Limit as x approaches negative 1 of f of x equals 1. Okay, well, before we even look at the graph, let's see what we have to check. We have to check that the limit as x approaches -1 from the left side and the limit as x approaches -1 from the right side, we have to check that both of these limits are equal to 1. So let's put question marks because we're not sure, we haven't checked yet. First of all, tackling the limit from the left side, as x approaches -1, here's -1 on the graph. And what is the y value doing as x approaches -1 from the left? So starting on the left and moving right towards x's -1. So what's the y value doing? Well, the y value is approaching right there, which is a y value of 1. So that means the limit from the left is indeed 1. And how about the limit from the right? The limit from the positive side, starting on the right, then moving left towards -1. Well, we start on the right, we move left, eventually we get up here, and then we're traveling down, down, down. As we approach -1 for x, the y value is approaching 1 also. So this is also true. Both the left and right limits are 1, so therefore the overall limit is 1. Now an interesting thing to point out is the overall limit is 1, but the function value is actually 2 at this point. So just remember, when you're computing these limits, it doesn't matter what the function actually does at the point, we're only looking as the function approaches a particular x value. The limit and the function value might be different, and that's totally fine, just like what happened here. Alright, next up, statement 2, the limit as x approaches 1 of f of x equals 3. What do we have to check without even looking at the graph yet? Well, we have to check that the left and right limits exist and are equal. So we have to check that the limit as x approaches 1 from the negative side and the limit as x approaches 1 from the positive side of f of x, we need to check that those both exist and are equal to 3. So again, we'll use question marks because we're not sure, we haven't checked this just yet. Okay, so where is 1 on the graph for x? Well, 1 is right over here. And as x approaches 1 from the left side, what is happening? Let's see. Well, as x approaches 1 from the left side, the function is on this branch. It's traveling up, 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 up. As x approaches 1 here, the function is still traveling up, up, up. It's approaching this point over here. And that point has a y-coordinate of 3. So yes, the limit from the left is indeed 3. But let's check the limit from the right. The limit as x approaches 1 from the positive side. So starting on the right, moving left. What is the function doing? Well, it's going up here and then down. And now it's approaching 1. It's going down, down, down. It looks like the y value is approaching 0 as x approaches 1. Yeah, it looks like it's trying to hit the x-axis. So no, the limit from the right is not 3, it's actually 0. So that means the left and right limits are not the same. The left limit is 3, whereas the right limit is 0. And because they're not the same, that means the overall limit does not exist. So it's not equal to 3, it actually does not exist. Alright, now let's check the third statement. Limit as x approaches 2 of f of x does not exist. Okay, so in order for this to be true, in order for the limit not to exist, we need to have that the left and right limits, so the left limit and the right limit, so those two from the positive side of f of x, either they are not equal or at least one of them does not exist. So let's check. First checking the limit from the left-hand side, as x approaches 2 from the negative direction. Here is 2, and we're approaching from the negative direction, so we're starting on the left, traveling right. And what happens to the y value? Well, the y value is traveling up, 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 up. As x approaches 2, the y value is approaching 2 as well. It's that point right over there. So this limit is 2. And how about the right limit? As x approaches 2 from the positive side, so starting on the right, moving left, the y value is increasing, going up, 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 up. As x approaches 2, the y value keeps on increasing until right here, the same point, y value of 2 looks like where it's trying to go. So the limit from the right is also 2. And is 2 not equal to 2? No, that's not right. We have that 2 is equal to 2. So the left and right limits both exist and are equal. So that means this limit does exist. Actually, it is equal to 2 because both the left and right limits are equal to 2. So statement 3 was false because it said that the limit doesn't exist, whereas we know that it actually does. Alright, so which of the following statements were true? Well, it was just statement 1. That was the only correct one. So that is our final answer. So now we know how to find the existence of a limit using one-sided limits. In the future, we'll continue learning more about limits, including limits at infinity and infinite limits.